Good day and welcome back to the Hopkins demonstration forest. This is part 12 of what is a forest. And today we're going to be picking up where we left off at part 11, and that's continuing to talk about some different tools that we use out here to take some measurements of our forest to ultimately help us make some management decisions or guide what we're doing out in the woods. So if you remember from part 11, we did horizontal distance. I showed you some different devices, different measuring tapes, kind of that basic one that we use out here, a logger's tape, pretty flexible tape that has a couple different multi-uses out here, but a tape measure. And then we ultimately determined or figured out a way to do our pacing to estimate horizontal distance by just walking. So horizontal distance, it's a great thing to have because sometimes we like to measure the lengths of roads. It tells us how to get from one area maybe to another if we're walking through a forest and we need to go a certain distance to do another plot. But that leads us to, I think, what I said before. You really need to have another device out there with you, and that's a map. So a map often has a scale on it. It tells you how far that horizontal distance that you're measuring relates to that map or the ratio. But you also need to have a direction in that horizontal distance. And so that's what gets us to the next tool that we use a lot out here. And I think most people have probably seen a compass of some type before. That's just kind of a very simplified view of one. Remembering the cardinal directions on the circle, straight up north, 0 or 360. 90 degrees is east, 180 down is south, and 270 to the west. Never eat soggy waffles. But we need to figure out that direction, so we don't just want a piece of plastic or a protractor. What we want to get is an actual compass. And some of you might have used a compass before, a very common tool. Manual oftentimes is great. They have electronic compasses. We have them on GPS units. You have them on your cell phones. But the nice thing about a tried and true compass is if it's in good functioning order, it doesn't lie to you, it doesn't run out of batteries. So one of the things this compass has, like all compasses, whether they're a couple dollars at the cash register at your outdoor store and meant to go on a keychain, all the way up to something that's a little more survey grade or daily used by a natural resource professional, is there's a needle that's floating in there in some type of liquid, sometimes just air, but that needle is magnetized, so a point on that needle, one of the ends, always points towards magnetic north. So we use a little fancier compass out here, and I encourage most people that do go get a compass or use them. You don't necessarily need the one that has the mirror on it. I'm not really going to talk about that today, except it's a way to improve our accuracy and to use this compass in particular. But a good compass has something called a declination adjustment. So one of the things that you need to make sure that you understand before using your compass is the difference between magnetic north, the direction that needle points, no matter where you are on this planet, it will point towards that magnetic location up towards the top of our planet. Notice I didn't say the top. So magnetic north is where the magnetic pole is located, true north, or where I sometimes like to say where Santa lives, up at the North Pole. Is slightly off depending where you are on the planet, and that's called our declination. So here in Oregon at the Hopkins demonstration forest, I think I checked, and I should have looked it up because you can check this on the web. I think we were just a little over 15, but 15 to 16 degrees east, meaning that when I want to go to the top of the planet or to the North Pole, my compass needle is actually pulled 15 degrees past that location to the east where the magnetic pole is located. So if I move across the country from the west to east coast, that declination changes. Some place over in eastern Texas, the declination is like 0, it's straight up. So that magnetic pole, which is located somewhere above Greenland, I think it was west of Greenland, it lines right up with the magnetic pole and the North Pole eventually, or true north location at the top. it's a very simple concept that gets very confusing very quickly for a lot of folks. So the best thing is to read the owner's manual specific to your compass. Find a YouTube video, kind of like this one, that might even go into some detail about that. But understanding that you need to set your declination anytime you travel with your compass, very important. A degree or two, not too big of a deal to be off. But when we're talking like being off 15 degrees, and I pull my compass out and I think I'm heading north, in reality I'm heading 15 degrees east of that location. Now, a couple hundred feet, probably not going to be off too far. But if I want to walk from up here at Hopkins and head all the way down maybe to the ponds and cover even a few hundred feet or a few hundred yards, after that I start getting off pretty far. And after a quarter mile or so of trying to navigate through the woods, you'd be way off your target. So very important to understand when we're measuring these horizontal distances and then getting a bearing or a azimuth angle on the horizontal is to make sure your compass is properly set up. So we'll be using that compass a little bit later. But there's another angle that we like to measure, and that is a vertical angle. So we've got our horizontal distance, we've got the horizontal angle or direction on that. Sometimes, and this is a little chart that I just pulled out for an example, sometimes we want to measure the height of a tree. So we don't climb to the top of the tree, but what we can do is some math and trig as we come back from the tree far enough, and we use a protractor basically, and measure these angles from our eyeball looking down to the base of the tree, or looking at the base and then looking to the top. Figuring out those angles, we can actually determine the legs of those triangles and get height. But a protractor is not the best way to go. It's not very accurate. It's a little hard to hold up and see through. So what we have is basically referred to as a look-through protractor. And if I held this thing up to the camera real quick and see if you can see in there, you'll notice if I hold it up and get it in there eventually, you'll see that there's a little dial. It's really kind of hard to line it up on the camera. But on that dial that you can look through there, you'll see two scales in this case. One is the protractor that we commonly used in math class, and that is a 0 to 90 degrees. So being straight or horizontal is 0. As I look up and tip the clinometer up, that scale that you kind of barely saw in there revolves up, and I can look up to 90, and then I can look down to negative 90. And that's a useful number to have, but something that we like to use a lot more in forestry is the ratio of a slope of a line, rise over run. So that the run, the distance out, and the rise, the distance up. So the rise over the run gives a slope, and you probably have seen that in like hiking trails or on roads. It says road grade ahead, 7% downhill road grade, or you're on a trail that's really steep and it's getting 20% slopes. So we often in forestry have that ratio of rise over run. That scale is also in here too. And we'll talk about how we use those to calculate different heights and aspects of our forest a little later. But basically looking through this, to look through protractor. Pretty durable, pretty accurate, and a tool we commonly carry. So a couple other things that are real important to have out there in the woods when you're especially doing some of these measurements. Can't say enough for taking notes, but a lot of times a clipboard and a blank piece of paper is all someone needs. But here in Oregon, and anywhere really in the forest, you encounter a lot of water. So we like to use field notebooks or paper that is all weather, right in the rain. Pencil, the best medium to use on that. But then that way, if it gets wet, your notes and your or even the stuff that you were taking out with you into the field to maybe directions, they don't fall apart when they get wet. And then lastly, a couple other things that are nice to have, things to help you see a little further away. Binoculars are kind of big and bulky, and I don't really need to use them that much, but something that I find really critical and is small enough to pack just about anywhere is a little magnifying glass. And you can get these in a variety of different sizes and powers. This one's fairly powerful. It's a 10 magnifier. So if I need to get a really close look at maybe a leaf or an insect or something that just hard to see, especially as you get older, I can get a really good close look at. And then another tool that we have that I've shown in a couple other videos is the Increment Core for boring into trees and taking out that core sample. Sometimes those rings that a tree puts on every year are really close together. Sometimes you're having a trouble seeing them, or you want to take a closer inspection. A little magnifying loop is phenomenal for that. So again, we've got our measuring devices. Sometimes they're in very cheap form, very usable. We're doing maybe a consistent plot size. So I talked about that in video 10. 37-foot plot, and for 1/10 of an acre, can be adjusted down to different size circular plots. Universal tape measure. Compasses, variety of different types. Make sure you know your compass, and then before you head out, make sure you understand how to use your compass. So every compass is a little different. And then the clinometer. So we're going to be using some of these tools a lot in some of the coming videos as I try to take you through some activities that we do out here in the woods. So I wanted to just introduce those now and don't have to worry about doing that later. So I look forward to seeing you out here again on video real soon, but hopefully out here live in person sooner than later. So thanks.